which condition this curve will have a real root or 3 real roots. Okay, but that is not
Yes.
part of your syllabus, so I'm not going to get there. Okay, but conceptually this is what it will look like. So it will have,
But
yeah,
so how will we realize how the graph will be like the curves you've made and the places where it's touching? How will we realize like what the roots are and how the graph will look like?
correct. So the that will depend on the coefficients, right? Let me
Hmm.
let me clear this. So again, we can visualize this in the generic form: ax cube plus bx square plus cx plus d, right? So it will depend on a, b, c and d, values of a, b, c and d,
Hmm.
right? Now in order to show you
Yes.
that, um, it will require calculus, but that's not part of your syllabus, so that derivation is not required.
Okay.
Okay, so what you'll be given is probably you'll be given a curve like this, and you'll be asked how many roots are there. You will not be
Hmm.
given this equation.
Okay.
Okay, so
Yes,
that's
sir.
out of your syllabus.
Hmm.
Okay, so this is the kind of question that might come. So how many roots does this have, or how many roots does this have, or how many roots does this have? That's the question that you will get. Simple.
Okay, sir.
Okay. Okay,
Hmm.
now let us do some um, exercises. Okay, let us cover one more thing on polynomials, which is division of polynomials, right?
Hmm.
Division of polynomials, right? So let's say I have a polynomial x to the power 6 plus 2x4 plus 6x minus 9, and I want to divide it by x cube plus 3. How will I do that?
We can divide it by long division method.
Hmm. How do we do that? It is just like any normal division, right? So
Hmm.
whatever
Yes.
we did, in school, in our earlier classes, exactly the same
Hmm.
way. X cube plus. The only thing that we have to do here is just be a little careful. See, in this case, they are given x to the power
Hmm.
6 and x to the power 4,
Yes.
but x to the power 5 is missing, right?
5 is not there.
So
Yes.
just take 0 into x to the power 5 plus 2 into x to the power 4. Again, x cube and x square are missing, so plus 0x cube plus 0x square plus 6x minus 9, right?
Hmm.
And we divide this by x cube plus 3.
Hmm.
So what we'll do is we'll look at the first term, x to the power 6, right?
Hmm.
And we divide it by the first term here. How much is
Yes.
that?
X is to power 3.
X to the power 3. So we write that here, just the way that we do normal division, right? Now
Yes, sir.
we multiply x to the power 3 with the whole thing. So that will give us x to the power 6 plus 3x cube. So it will come here, 3x cube, right?
Sir,
Yeah.
it'll be x raised to the power 2.
Which one?
The first one, because if we multiply the whole equation,
This one?
then it'll become yes.
No. What
I know it's 6. We take 6 minus 3,
is 3?
but if we take x cube into x cube plus 3,
See, what is
then
x?
it'll
Hold on. What is x6? X into x into x into x into x into x, right? And I'm
hmm,
dividing this by x into x into x, right?
hmm,
So what happens? 1, 2, 3. How many are left?
3.
So yesterday we did this, right? X to the power a into x to the power b is x to the power
Hmm,
a plus
aim,
b,
hmm,
right? So x to the power
yes,
3 into x to the power 3 is x to the power 6. X to
hmm,
the power a by x to the power b is x to the power a minus b. So x to the power 6 by x to the power
okay,
b is x to the power 6 minus 3. Okay,
okay, sir. Hmm.
clear?
Yes, sir.
Okay, okay. So we have x to the power 6 here and 3x cube here. So I subtract this as we do normally for our division. So this becomes 0, and then we have 2x4 and minus 3x cube. This is what we have, right? And
Yes, sir.
we have plus 6x minus 9. So again we do the same thing. We take the first term, which is 2x4, and
Hmm.
divide it by the first term here, which is x cube. So
Yes, sir.
that gives us 2x, right?
Hmm.
So we write 2x here, and we multiply 2x with the whole term. So we get 2x to the power 4 plus 6x, right?
Yes, sir.
So again we subtract
Hmm.
this. So this becomes 0, minus 3x cube remains. This becomes 0, minus 9. So again I repeat the same thing. So minus 3x cube by x cube is minus 3, right?
Hmm.
So I write minus 3 and I multiply minus 3 with the whole thing. So I get minus 3x cube minus 9,
9.
and I subtract this. So this becomes plus, this becomes plus. So
Hmm.
this is my answer,
Hmm.
right?
Yes, sir.
Okay. Let us take one more example. This one, you tell me how we'll do it.
Okay, sir.
So we will do 2x square minus 5x minus 1 divided by x minus 3.
We'll divide 2x square by x and we'll get 2x. Then we multiply 2x with x minus 3. We get 2x square minus 6x, which will become minus 2x square plus 6x. There will be minus x plus minus 1
No.
plus x minus 1. Okay, wait, both are. So the minus 6 will become plus.
Correct. So plus 6x minus 5x will be plus x.
Yes. So
So next,
we divide x by x and then we'll get plus 1. Then we multiply that by x minus 3. We'll get minus x plus 3, which will be 2.
then
How do we divide it further?
we cannot. So
Yeah, so it's the remainder.
2 is the remainder. So whenever you get a
Okay.
constant term, that becomes the remainder. So that means
Hmm.
2x square minus 5x minus 1 divided by x
Hmm.
minus 3 will be equal to 2x plus 1 plus 2 by x minus 3. Clear?
Okay.
Clear?
Hmm. Yes, sir.
Okay. Now let us also cover one more thing, which is how are the roots related to the coefficients of a polynomial, right? How are the roots related to
Yes,
the
sir.
coefficients of a polynomial? This is very, very important, right? So
Okay.
let's say I have a equation um, y is equal to a into x to the power n, sorry, a0 to the into x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 and so on till I have a n, right?
Yes, sir.
How many terms are there in this equation?
Infinite.
Sorry, how many terms?
There are
A1, A2. What is the
hmm.
last one? AN. How many terms?
Yes. 3.
No, there are a lot of terms missing.
It's in.
So
Yes.
it is 1, 2, 3 up to n. So how many terms? N terms.
Infinite. Yeah,
N,
n terms.
n terms plus 1
Hmm.
because A0 is also there,
Yes.
right? So
Yes, sir.
we have n plus 1 terms here, right? Now
Hmm.
let us assume that x1, x2, x3, etc. are the up to xn are the roots of the equation. This is equal to 0.
Hmm.
Are the roots of y, right? Are the
Yes,
roots
sir.
of y. So how can we write y in terms of the roots? How can I write y in terms of the roots? Okay, uh,
Hmm.
not x1. Let me put this as a1, a2. a1, a2, a3 up to an are the roots of the equation y,
Hmm.
right?
Yes, sir.
So how can I write y in terms of the roots? Okay, let us look at a simpler equation. Y equal to x square minus 3x plus 2. How can we
Hmm.
get the roots?
By middle term splitting, we can.
Right? So
Yes.
we can write this as y equal to x minus 2 into
Hmm.
x minus 1, right?
Yes.
Where 1 and 2 are the roots of the equation,
Hmm.
right? So if a1, a2, a3, an are the roots of the equation here, then how can I write y in this form? See, the form is y is equal
Hmm.
to x minus root 1 into x minus root 2,
Hmm.
right? Because there are
Yes,
only
sir.
two roots here. But if there are n
Hmm.
roots, then we'll have the same logic. We will write this
X
as
minus n.
x minus a1 into x minus a2 into x minus an, right?
Hmm.
This is how we can write,
Yes, sir.
right? Okay. But before I do that, um, let me simplify this equation a bit more. I can write this as a0 into x to the power n plus a1 by a0 into x to the power n minus 1 plus a2 by a0 x to the power n minus 2 and so on. And the last term will be an by
Hmm.
a0, right? Now, if I do this,
Yes, sir.
then I can clearly see that there are n roots because x is to the power of n,
Hmm.
right? Correct?
Yes, sir.
Okay. So therefore, I go back to this equation itself. So now what we have written is correct, right? There's no problem with that.
Yes.
Okay. Now, therefore, this and this are the same. Both are equal to y,
Hmm.
right? So I can write a0 xn plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 up to an is equal to x minus a1 into x minus a2 up to x minus an, right?
Yes, sir.
Now, look at this equation. here we have a total of n terms from a1 to an, right?
Hmm.
We have a total of n terms. Now what we will do is we will equate the coefficients of the powers of x from both sides, right? So here you see that x into x into x into x into x. So there will be an x to the power n term here,
Hmm.
and here I have a0 x to the power n.
Yes, sir.
So this and this should be equal.
Yes, sir.
So therefore a0 is 1 here, right?
Yes, sir.
Now next we come to x to the power n minus 1. How do we get the power of x to the power n minus 1 here?
We equated with x minus a2.
Yeah. So you see that in each of these terms, when the constant term, right,
Hmm.
multiplies with the x term of the next one, we will get a1x minus a1x, again minus a2 into the next x, right?
Yes.
And this will go on. So this will be up to minus a n minus 1 x, right?
Hmm.
Correct?
Yes, sir.
So, okay, sorry, my mistake. We are doing x to the power n minus 1. So x to the power n minus 1 would be when all these x terms are multiplied except the first one. So x of
I
here,
didn't
x.
get you, sir. I can't hear you.
Okay, let me clear this up.
Hmm.
So we have x minus a1 into x minus
Hmm.
a2 into x minus a3 into x minus a4 all the way up to x
Hmm.
minus an, right? Right?
Yes, sir.
So there,
Yes,
there,
sir.
there will be a term where we will have x from here, 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 right? So
Yes, sir.
there are total n terms here, and I'm leaving out one term. So if I multiply the x of the other terms, I will have x to the power n minus 1,
Yes.
right? And with that, I
Yes.
will multiply the constant term of the uh,
Hmm.
first term, right? So
Hmm.
what I'm doing is I am just taking this term out and I'm multiplying the x terms of all the other terms. So that will give me x to the power n minus 1.
Yes, sir.
And with that, I am multiplying the constant term of the first term, which will give me minus a1 x to the power n minus 1.
Yes, sir.
Next, I cannot do this only for one term, right? I have to do it for all the terms. So the same thing I will do. I will keep x minus a2 out and I will multiply the x terms of all the other terms. That will give me x to the power n minus 1. And with that, I will multiply the constant term of the second one,
Yes, sir.
right? And I have to do this for all the terms one by one. So it will be minus
Hmm.
a3 x to the power n minus 1 and all that, right?
Hmm.
Correct?
Yes, sir.
All the way up to minus an x to the power n minus 1. Correct? Because the last
Yes.
constant term is an, right?
Yes, sir.
Now this means that minus of a1 plus a2 plus a3 plus a4 all the way up to an
Hmm.
is the coefficient of x to the power n. Sorry, x to the power n minus 1, right?
Yes.
And on this side we have a1
Hmm.
is equal to a1, right?
Yes, sir.
So that means the sum of all the roots, this is the sum of all the roots, right? With a negative sign of all roots is equal to a1, right? Is this clear, or you want me to explain again?
Okay.
Okay, let's do this once
Can you
again.
Yes.
Okay, we had y equal to a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 all the way up to an x to the power n, right?
Hmm.
This is what we had, right? In
Yes,
order to
sir.
find the roots of the equation of this expression, we have to equate it to 0, and by doing that,
Yes.
let us assume that the roots are a1, a2 all the way up to an, right?
Yes, sir.
So we can write this in the form x minus a1 into x minus a2 into x minus a3 all the way up to x minus an
Yes, sir.
is equal to this whole thing
Yes, sir.
plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 all the way up to an, right?
Yes, sir.
So now what I'm doing is I want to equate the the coefficients of all the powers of x. So I start off with x to the power n. Now how can I get x to the power n? So I will get x to the power n by multiplying all the x, n terms
Hmm.
are there, right?
Yes, sir.
So if I do that, x to the power n will have a coefficient of 1 here, and here I have a0 x to the power n, right?
Yes, sir. Hmm.
So therefore I get a0 equal to 1, right?
Yes, sir.
Now if I want to get the coefficient of x to the power n minus 1, that means I have to take all the x one by one. So that means first I will keep this out. I will multiply all the x's of the rest of the terms. So that will give me x to the power n minus 1, right? With that, I
Yes,
multiply
sir.
the constant term of the first one, right?
Yes, sir.
Next, I I keep this out and I multiply all the x's of the other terms. So there are n minus 1 terms, right? X to the power n minus 1, and I multiply the constant term, right?
Yes, sir.
You're getting this, right? I'm
Yes,
just
sir.
I'm just keeping one of the terms out and just multiplying
Hmm.
the excess of all the other terms. So there are n minus
Hmm.
1 terms. So x to the power n minus 1, and then I'm multiplying it with
Hmm.
the constant term of the one that
First.
I've left out.
Yes.
So if I do this, minus a3 x to the power n minus 1 and so on, all the way up to minus an
A. Hmm.
x to the power n minus 1, right?
Yes, sir.
And on this side, I have a1 as the coefficient of x to the power n minus 1, right?
Hmm.
So therefore, it is minus of a1 plus a2 plus a3 all the way up to an x to the power n minus 1 is equal to a1 x to the power n minus 1, right?
Yes, sir.
So that means that a1, a2, a3, an are all roots of the equation.
Yes, sir.
So I can write this as minus sum of the roots is equal to a1, because this whole thing will be equal to a1. The coefficient of x to the power n minus 1 on both sides, they have to be the same, right?
Yes, sir.
Clear?
Yes, sir.
So sum of the roots minus sum of the roots is equal to a1, right?
Yes, sir.
So sum of the roots will be equal to minus a1,
Hmm.
right?
Yes, sir.
Similarly, and we can write this as minus a1 by 1, and we have found a0 to be 1, so this will become minus a1 by a0 in general,
Yes, sir.
right? Now, similarly, we can do this for other terms. So if I take x to the power n minus 2 now, so that means I have to keep two terms out and multiply the x terms of the rest. So then I will get x to the power n minus 2, and with that I will multiply the constant terms of the first two terms, a1, a2, right?
Yes, sir.
Similarly, I can do with 1 and 3, so a1, a3, x to the power n minus 2, a1, a4, x to the power n minus 2, right? Like this. And then
But
a2, a2, a3.
why aren't we leaving it? Why aren't we leaving it out like we did in n minus one?
Yeah, in n minus x to the power n minus 1, we left out one term at each time, one term each,
Yes.
right? Now,
Hmm.
because I want to get x to the power n minus 2, so I have to leave out two terms because there are total n terms. So I have to leave two
Okay.
terms to get x to the power n minus 2. And
Okay.
the terms that I'm leaving, I will multiply the constant
Hmm.
terms of those terms with x to the power n minus 2. So the series will be like a1, a2, a1, a3, a1, a4, and then a2, a3, a2, a4, and so on,
Okay.
right? So that means
Yes, sir.
all this ai, aj, the summation of that will be equal to the coefficient of x to the power n minus 2 here, which is a2, right? So that means
Yes, sir.
sum of product of the roots taken two at a time. is equal to A2 by 1, which is A2 by A0,
Yes.
right? So
Yes, sir.
this is how you can equate the roots of the equation with the coefficients, right?
Yes, sir.
This is how you can equate the roots of the equation of the expression with the coefficients, right?
Yes, sir.
Now, why did we do all this? What is the meaning of doing all this? So, if I have an equation y equal to 7x squared plus 4x plus 3, okay,
Yes, sir.
what would be the sum of the roots?
Then we'll equate them and add them.
No, so we just saw that sum of the roots is equal to minus of a1 by a0, where a1
Yes.
is this, a0 is this. So sum of the
Yes, sir.
roots here would be minus 4 by 7,
Hmm.
right? And what about the
Yes.
product of the roots? Now, in order to get the product of the roots, we go back to the earlier one.
Hmm.
So x minus a1 into x minus a2, x minus a3 up to x minus an, right, is equal
Hmm.
to a0 x to the power n plus a1 x to the power n minus 1 all the way up to an. Now, if I want the constant term from both sides, so I have to multiply all the constant terms. So
Yes,
A1,
sir.
A2, A3 all the way with a minus 1 to the power n, because each one has a minus 1, right,
Yes, sir.
is equal to an by a0,
Yes, sir.
right?
Yes, sir.
So therefore, minus 1 to the power n into product of roots is equal to an by a0. So if I have the equation like this, 4x plus 3, what will be the product of my roots? What is n here in this case?
7x raised to the power 2.
No, 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 no. What is the value of n here in this case? What is the highest power of x?
2, 2. It's
Correct.
2.
Here n is equal to 2, right? So minus
Hmm.
1 into product of the roots, minus 1 to the power 2 into product of the roots is equal to how much here? What is a,
Y.
what is an here? An was the constant term. What is an here?
3.
3. What is a0 here?
4x.
A0.
No.
A0.
Y. Y.
No, 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 no. A0. A0 is the coefficient of the highest power of x.
7x.
Not 7x. 7. It's just the
Yeah,
coefficient.
7. Yes, yes.
Okay. See, A0, A1, A2 all are constants. Okay. So
Hmm.
these are the coefficients. So minus 1 square into product of the roots is equal to 3 by 7. Right? 3 is A0,
Yes.
sorry, 3 is An and 7 is A0. 3 by
Yes.
7, right?
Yes, sir.
So this is how it is used in quadratic equations, right?
Yes, sir.
Now, what about cubic equations? So in cubic equation, let's say y is equal to 4x cube plus 3x square plus 2x plus 1, right? What would be the sum of the roots?
2x plus 1. We'll use the same formula for the product of the roots as we used for the an for our cubic equation.
Yeah, correct. So this is a cubic equation. So what would be the value
Hmm.
of n here?
3.
3. N is the highest power of x, always,
Yes.
right? So n is equal to
Yes.
3. What is the value of A0 here?
A0 is 4.
A1,
A1 is 3.
A2,
2.
and A3.
There is no A3. But wasn't that an because it's a constant?
Yeah, because n is 3 here.
Okay, yeah.
So
Yeah, yeah.
an becomes A3 here,
Yes, yes.
right? So the
Hmm.
last term is 1. So an is 1 here, right?
Hmm.
So sum of roots. So okay, now let us name the roots. So let the roots be alpha, beta, and gamma, right? So alpha plus beta plus gamma would be how much?
6.
Alpha plus beta plus gamma is what? Sum of the roots we saw was
Yes.
minus of sum of the roots
Hmm.
was a1 by a0, right? So
Yes.
sum of the roots is minus a1 by a0, right? So what is the value of a1 here?
Minus 3. So minus 3.
Minus a1 is 3, a0 is 4,
Hmm.
right?
Hmm.
What would be alpha beta plus beta gamma plus gamma alpha here? That means product
The
of the roots taken two at a time, sum of that.
it will be minus 2 upon 4. It'll be half.
No, it won't be minus, it would be plus half. See, remember
Okay.
this, remember this. You have a minus with all the coefficients, right?
Hmm.
So whenever you are taking the even power, which means alpha, beta plus gamma, the minus will remain. Whenever
Hmm.
you are taking product of two, so that means minus into minus, which is plus.
Hmm.
Okay. What would be alpha, beta, gamma? So this is minus, minus, minus. So this will be minus,
Yes.
right? And
Minus huh.
how much will that be?
Minus 1 upon 4.
Minus 1 upon 4. Got it?
Yes, sir.
So this is the kind of problem that you will get in the examination. Okay. Now just to make it simple, let me tell you one uh, very simple thing to remember. So if you have a quadratic equation, ax square plus bx plus c, then sum of roots are alpha and beta, then sum of
Hmm.
roots alpha plus beta will be minus the coefficient of x divided by coefficient of x square, b by a, right? And alpha into beta would be equal to c by a because it will be positive, right? Just give me 1 second. স্যার জাস্ট 5 মিনিট দিন, আমি পড়াচ্ছি, শেষ করে আপনাকে কল ব্যাক করছি। হ্যাঁ হ্যাঁ হ্যাঁ, শিওর শিওর, আমি রাইট। So if it is quadratic, so alpha plus beta would be,
Sir, I didn't hear you at all.
okay, let me repeat this. So if it is a
Yes.
quadratic equation, generally of the form y equal to ax square plus bx plus c, right? So this, if the
Yes,
roots
sir.
are alpha and beta, then alpha plus beta, you always do it like this. You just take, you just start from the highest power of x. Here it is x square.
Yes.
Just go to the next term, take that coefficient with a negative sign, okay, and divide by the
Hmm.
coefficient of the highest power of x. This would always be the sum of the roots. So if it is quadratic, it would be minus b by a. If it is higher powers, let's say ax cube plus bx square plus cx plus d,
Hmm.
there also alpha plus beta plus gamma would be minus b by a. So this remains the same. Sum of the roots will be the coefficient of the second highest power of x divided by the highest power of x, negative of that.
Hmm.
Okay, so this is
Yes,
always the
sir.
sum of the roots. And product of the
Yes.
roots, which is alpha beta here, will be c by the constant term divided by the coefficient of the highest power of x with a minus 1 to the power of the highest power of x. In this case, it is 2.
Hmm.
If it is 3, then alpha, beta, gamma would be d by a into minus 1
Hmm.
to the power 3. That means minus d by a.
Yes, sir.
Clear?
Yes, sir.
And in this case, in case of a of cubic equation, there will be one more term which is alpha beta plus beta gamma plus gamma alpha, which is the sum of the product of the roots taken two at a time. That will be
Yes.
c by a, and because they are paired with 2 each, so minus 1 will not be there, it will be plus 1. So c by a, right?
But sir, won't it be A2 upon A0? So the second one,
Which one?
C by A is A2 upon A0.
A 2 upon, yes, that's what I'm doing.
Okay, yeah. So it's C.
See, the general rule is this: sum of roots. This is always minus of uh, b by a. And remember this like this: y equal
Hmm.
to ax to the power n plus bx to the power n minus 1 plus cx to the power n minus 2. Like this, it goes on, right? So if this is the case, then sum of roots is equal to minus b by a. So b is the coefficient of the second highest power, a is the coefficient of the highest power,
Yes.
right? Then sum of the roots paired together. That means alpha beta plus beta gamma plus gamma alpha like this, right? This would be equal to C by A, will always be equal to C by A,
Hmm.
right? Because
Yes,
since
sir.
this is paired together, so -1 into -1 would be always +1.
Yes, sir.
And alpha, beta, gamma will always be equal to the last coefficient, last term, which is the uh, constant term divided by A into -1 to the power n. So this will vary between positive and negative depending on n.
Hmm. Yes, sir.
Clear?
Yes, sir.
Okay. Any doubts you have on this?
So not right now. If I have any, I'll ask you tomorrow.
Yeah, sure, definitely. Okay. So is there any
Yes,
other
sir.
topic on polynomials that is left?
1 second, let me check. No, sir.
Okay. Just let me double check what we are going to do tomorrow. Okay, tomorrow we are going to do arithmetic progressions, right?
Okay, sir.
Do you have geometric progressions as well?
No, sir.
You don't, right? Okay. So we'll do
No.
arithmetic progressions tomorrow, right? Now, I want to
Yes.
show you one more thing. Uh, I want to show you one more thing here. I can give you exercises on this site. I can send you the link,
Okay.
right?
Okay, sir.
Let me show you how it works. Yeah. So you will you'll be assigned in a class, and you will see you know. Okay, this is probably not the best example to show. Uh, 1 second. Yeah. So you will see questions like this. It can be multiple choice or you know descriptive answers as well, right? And
Yes, sir.
you have to take the test, right? So
Yes, sir.
I'll prepare some questions and I'll send it to you based on what we covered yesterday and today.
Okay, sir.
Yeah. Okay.
Yes, sir.
So we meet
Yes,
again
sir.
tomorrow same time, and uh, let me know if you have any doubts or anything that we want to revise again.
Yes, sir.
Okay.
Yes,
Okay.
sir.
Okay
Thank you,
then.
sir.
Take care. We meet again tomorrow.
Yes. Yes,
Bye.
sir. Thank you.
Thank you. Bye.